Thank you. So we have this giant reveal, but I'm going to do it anyway. So in the land of distributed microservices, how can we secure service-to-service communication in a highly distributed environment, all the while considering system resiliency and reducing our developer pain points? Cody and I hope to highlight this in Nordstrom's journey towards service mesh, there and back again. Morning, everyone. Welcome. We're glad you took the time to come here and attend our talk. My name is Hema Lee, as Risha introduced us, and I'm a senior engineer at Nordstrom. My teammate Cody and I represent the networking team in our engineering platform organization. Our team devises solutions that protect the flow of traffic between services in Nordstrom's compute environment. A little bit about Nordstrom. We are the leading fashion retailer that was founded in Seattle in 1901 as a shoe store. Today, we serve our customers in more than 380 stores in 40 states in the US, Canada, and Puerto Rico. In fact, we recently opened our New York City flagship store in Midtown Manhattan. So if you are in town, please check us out at 57th and Broadway. So our tale this morning evolves from why we considered a service mesh, the investigations we considered, and the best options for Nordstrom. Then Cody will walk you through our rollout and some of the gotchas we encountered during our installation, which led to some contributions to the community. Lastly, we hope to share some tidbits that we hope you'll find useful, and then open it up to Q&A. So how do we come to discuss a service mesh? Let's look at what a service mesh is. One of the most common definitions that I found states that a service mesh is a dedicated infrastructure layer for facilitating communications between microservices. When we first considered a service mesh, the landscape at Nordstrom looked like this. Each of the service teams owns their own tech stack, and the apps were built with a variety of tools and languages. When teams have to factor in the configuration and management of these tools, they are wasting valuable time that could be better spent handling business requirements. As the engineering platform team, we knew that we could help standardizing these areas that you see in gray: tracing, service discovery, routing, encryption. By adding the sidecar proxy that you see in blue, we're able to decouple the services from the app and make them language agnostic, thus allowing us to standardize the tools that teams would be able to use. So what else can we accomplish by integrating with service mesh? Our list of internal services is constantly growing to be able to fulfill the needs of our customers. Our technology teams design solutions across the broad range of store and online services. Additionally, these services have to operate seamlessly via our mobile app as well as our website. We have to ensure our core priorities are met. So what are our core priorities? We need to make our applications and services highly available so they can serve our customers and employees with minimal disruption. We cannot diminish our customer experience by taking hours to bring our site back up online. Consistency and observability is also key. We also need to make a smooth experience for our developers to onboard to using our service, and to offer them access to metrics and logs so they will not have to configure it themselves. We need to offer clear benefits so that our developers' teams want and ask to use our service rather than be forced to onboard. It's a necessity that we can handle traffic spikes with minimal overhead and still be operational. We hold 2 big events each year: our anniversary and holiday sale. In addition to these events, there are numerous small events for product launches. Latency is a critical metric, especially during these major sales, and our footprint needs to be small. Last but not least, securing communications is hard. How many of you have had an outage due to an expired cert? Don't be shy. That's happened to us too. One of the biggest pain points we heard from our developers is how much they have to keep track of the certificates we need. We needed to secure communications between our internal services, either through MTLS or through authentication, authorization, or both. So what environment should we focus our priorities on? When we started down this path last year, we had to understand what these environments were and where developers like to deploy their services to. We had services running on AWS EC2 instances, on-premises VMs, serverless functions, and in our Kubernetes clusters on both AWS and GKE. To give you an idea, we had about 6,680 total pods in both of our production Kubernetes clusters. We averaged about 3,000 Lambda functions daily, 7,000 production VMs in our on-premises servers, and we had about 6,000 production EC2 instances running. With numbers like these, we couldn't focus our efforts on all of these environments. Our mindset was to ultimately craft a solution that would work for our services that run on the cloud as well as on-premises, specifically in our Kubernetes clusters. We anticipated that the majority of our services in the future will be deployed into K8s. To give you an idea, during our anniversary sale this past July, we scaled up to running more than 12,000 pods and 36 terabytes of RAM in the first 30 minutes in both our production K8s clusters. We had one service alone scaled to running 3,000 pods. These numbers are telling us that implementing for the cluster was the right path. So how do we go about finding a solution? We considered a wide variety of options, including spending months designing and building our own solution from scratch. But why re-engineer what's already been created? So we scrapped our solution and looked at the options that we could either buy or looked towards the open source community. To use an open source project would allow us to quickly, reliably, and economically implement a solution to help serve our customers better. To use an open source software would also integrate well into our development environment. It would also give us engineers a chance to contribute and collaborate with teams outside of Nordstrom. But we did have other things to consider besides how performant and secure a project is. Being a large enterprise, we needed to look at the number of contributors, the community support for the project, and the engineering team's ability to work with us. In the end, we chose the open source route, as one of our company's values is to contribute back to the community. And this gives us engineers a chance to have that sense of accomplishment too. So what do we have on the table? Among the options that we looked at were Istio, Aspen Mesh, and LINKERD. It was great to be able to work with the engineering teams of each of these products and the help we received as we refined our configurations and testing parameters. But ultimately, they were all good choices for us, but we chose LINKERD. So LINKERD is described as an ultralight service mesh for Kubernetes. It gives you observability, reliability, and security without requiring any code changes. The performance tests we conducted here were for scalability and load testing. Our benchmark, we used a benchmarking tool called Work2, through which we looked at two use cases, an above average daily workload and an anniversary load. The latency numbers that you see here are for P90. The tests for the above average daily load were run at 500 requests per second at 1,000 concurrent connections, resulting in a latency of 3.70 milliseconds. The test for the anniversary load was run at 5,000 requests per second, also at 1,000 concurrent connections, resulting in a latency of 4.23 milliseconds. Additionally, even running at a large scale, the pod memory usage does not exceed baseline. Since we ran these tests, our load testing numbers have risen significantly, but LINKERD has certainly met our requirements as being a lightweight proxy that fits into our roadmap for the future. So who gets to hold the keys to this project? Since our team's main charter is to secure communications between all of Nordstrom's services, whether they're hosted on premises, in AWS or GCP instances, or in our company's K8s clusters, we should be involved in some way, I think. However, the logical choice to lead the effort would be our K8s team. They are the dedicated experts tasked with maintaining and supporting all things related to the cluster. But with so many features available that can extend the Kubernetes-based platform, our respective teams decided that K8s can graduate from being the sole responsibility of one team alone. Hooray! My team just picked up the keys, and we get to drive the direction of this project. Cody will continue our tale of integrating our service mesh solution with our enterprise clusters.
Thank you, Hema, and hello, everybody. My name is Cody, and I'm one of the Nordstrom engineers responsible for implementing our service mesh solution over the past year. We've just heard why we want to use a service mesh, and now I'm going to describe how my team managed to get our service mesh solution production ready. So we're going to talk about how we had to quickly come up to speed on Kubernetes. We're going to talk about, actually, we're going to watch what happened when we tried to install LINKERD for the first time on our production clusters. We're going to discuss some challenges that we faced as we were moving towards production readiness. And we're going to talk about how we were able to work with the open source community to overcome these challenges. So although Nordstrom has been using Kubernetes for years now, we were one of the early adopters of Kubernetes, my team was most experienced with designing front-end applications for mobile. So most of my team was brand new to the Kubernetes ecosystem, and we found ourselves in the position of needing to learn as much as we could, as fast as we could. So the first thing we did was go to the Kubernetes website and read about what is Kubernetes. So the description you see here has a lot of keywords that I've highlighted that stood out to us as developers. So it's portable, extensible, open source, declarative, and automation. So given Nordstrom's situation, this description appealed to us. We had been breaking up large monolith services for years. There was a desire to increase developer productivity through the use of CI/CD automation for our services. And we also wanted to have a common platform for our service teams to use so that they can focus on delivering features and not worry about things like certificates. There's always a desire to reduce costs, and packing as many services as we can onto an instance is one of those ways to reduce some costs. So we've learned that Kubernetes is a platform for managing containers. So now what we had to do was figure out what a container was. And once we learned about containers, we needed to know a bit about the Kubernetes networking model, and on and on and on. And it felt like we could get lost in all of these technologies. So in addition to these various technologies that we needed to learn, there were a few other dragons we needed to slay. We had to learn and become familiar with new terminology, things like pods, deployments, replica sets, cluster roles, webhooks. Even words that we were already used to using, like services and endpoints, were being used in a new way. For these, the Kubernetes documentation we found was really well done, and it helped us learn immensely as we were going through this process. So in addition to this new terminology, there are a whole set of new tools to learn. kubectl, Minikube, even Go was new for us. Finally, we needed to figure out how we could deploy test and development clusters so that we didn't bring down anything in production. So we started with Minikube, as most people do. And while Minikube is certainly great, we needed something that was more closely related to our actual environment that we were going to be deploying to. So we needed to work with our Kubernetes team to figure out how we can run these clusters in our AWS account. At Nordstrom, we use a multiple account model for AWS, and that means each team has their own AWS account. So in order to make these changes, we needed to talk with yet another team in our enterprise about how we could get the appropriate access permissions to resources. Also, we had cost concerns. So we were going to be spinning up new clusters in our accounts, and there were some concerns about how much that would cost. We ended up figuring out that we could spin up and down clusters on a daily basis so we could keep those costs down. Our existing Kubernetes team has a ton of tooling already in place to deploy their development clusters to their accounts, but we needed to work with them closely to adapt their tooling for our needs. So after many hours reading documentation, watching videos, and tutorials, we decided that we were ready so bring on the service mesh. So now that we've come up to speed with Kubernetes, it's time to install and run the service mesh. But first, we're going to talk a little bit about how LINKERD works. You can see here an architecture diagram that shows the various components that make up LINKERD. On the top, you've got the control plane. It has components for things like aggregating telemetry and metrics. It provides a user-facing API for their dashboard and the command line tools. And also, there's a service that's particularly of interest to us that we'll talk about a little bit later, so the LINKERD identity service that is responsible for issuing certificates. The data plane at the bottom consists of the sidecar proxy that is injected into each Kubernetes pod in the service mesh. The sidecar proxy injection typically includes an init container that is responsible for writing the IP tables for the pod. These rules are configured so that the LINKERD proxy can intercept all the outgoing traffic and incoming traffic, and this is how they're able to add their features like MTLS, traffic observability, load balancing, and things like that. So now that we know a little bit about LINKERD, let's go ahead and install it. So we went to the Getting Started website. We did what most people do, found the instructions to install LINKERD, and it looks like installing LINKERD is easy. It says so right there. So let's give it a go. So first, we're going to run the install LINKERD command, and we're going to see what happens when we do that. So we see some services being created. We've got the identity service being created. That's great. This is a service that's responsible for issuing certificates. We're going to see some more services created. We've got the controller and the proxy injector that's going to help us inject our proxies. And a whole bunch more resources were created, about 45 more in this particular case. So let's take a look and see what happens. So we're going to take a look at our service mesh pods. So this was our first problem here. It says no resources found, although it just told me that it created about 48 resources. So we need to figure out what's going on. So we're going to look at our deployments. And sure enough, none of our deployments are ready. So we need to drill down and figure out why. So we're going to take a look at our replica sets and our deployments to see if there's any Kubernetes events that can help us figure out what's going on. So it looks like we were unable to create a replica set because of some various failures. Apparently, we're not able to validate against a pod security policy. We can't run as root. This net admin capability, we can't have that. And this net raw capability, we can't use that either. So what is a pod security policy? What is net admin and net raw? We just want to install our service mesh. At the time, we had no clue what any of this meant, since we hadn't seen any of these errors on our test clusters. So the initial failure to install LINKERD was definitely a surprise for us, and it presented us with our first real challenge. How are we going to install LINKERD on our cluster? And why did this work in our test environment? Have any of you been in this situation? Tasked to implement something that was supposed to be easy, but then at the very first step ran into roadblocks. So now to be fair, these instructions will definitely work for most clusters and most teams. But apparently our Nordstrom production clusters are configured a little bit differently than most instructions assume. And the main difference is that they are configured for the highest security. So over time, our Kubernetes team has put in place security measures that include pod security policies, LDAP access control, and the principle of least privilege. These measures, along with many others, secure our cluster for the hundreds of service teams using it. So our first challenge was realizing that we're not cluster administrators. And really, this shouldn't have been a surprise. We should have known this. But it was a surprise for us at the time. We also don't want to be cluster administrators. We want to keep the cluster administrators, the count to a minimum, due to the types of data present in the cluster and the types of communication between our services. So not being administrators means that we can't just create cluster roles and modify policies in order to make our service mesh work. So if we need a cluster-wide resource or if we need to modify something, we need to talk with our Kubernetes team. We need to reach out to them and we need to tell them what they need or what we need, and they help us get what we want. They ask us some very tough questions. They look over every line of YAML that we submit, and they ensure that we're only getting what we ask for and what we need. The security of our cluster is a top priority. So the second challenge was figuring out what to do with this pod security policy. A pod security policy is one way that our cluster administrators have controlled our security requirements for the pod. They can control things like port numbers that are allowed, user IDs, and specific Linux capabilities that are allowed. So the errors we were seeing meant that we were in violation of this pod security policy, specifically that must run as non-root property and the request for netadmin and netraw capabilities. So if you remember, the LINKERD proxy uses IP tables rules to intercept incoming and outgoing traffic. Well, in order to write these IP tables rules, a process needs to be root. Or more specifically, a process needs to have the capabilities capnetadmin. And this capability allows users to administer the firewall, modify routing tables, bind to any address, and generally other things that shouldn't be allowed in a multi-tenant cluster for most users. If a user had this capability and they wanted to, they could likely inspect all traffic coming in and out of the pod or even on the node. So there's a very good reason why our team has denied this capability for us. So because the controls are linked to service accounts in Kubernetes and not pods, if we granted a security exception for a service account, then anybody with that service account could also have this capability, and we didn't want that. So now we had to figure out how to use LINKERD given this pod security policy. So to do that, we worked with a vibrant open source community surrounding LINKERD. We chatted with the LINKERD engineers and our own Kubernetes cluster team to figure out a solution that would work for us. So during our discussions, it was suggested that a CNI plugin would be one way of solving our issue. This would allow us to run a custom binary whenever a pod is created, and that binary would be able to write the IP tables rules for that pod. Because the CNI plugin process runs on the node itself, there are no special capabilities that you need to give a service account. And the pods no longer need to ask for netadmin or netraw. So the other appealing feature of the CNI plugin is that we can chain them together. And so our new plugin would be able to move into where the other existing plugins that we had in place. So we went forward and created the CNI plugin. I don't know how many of you ever tried to create a CNI plugin, but for us, I remember this particular story when we were just simply trying to verify that what we had written was going to work. And because we're running in a cluster on a remote machine, the typical application developer tools like debugs and breakpoints and stuff weren't available to us as far as we could tell. So we had to figure out another way. So we put in print statements, right? That's what people do. So as we were doing this, our plugin wasn't working, and we didn't really understand why. And I remember inviting a colleague over to look over my shoulder, and to him, everything looked great too. It turns out that CNI plugins communicate via the standard in, standard out using a specific JSON payload. And what we were doing was putting our print statements into the standard out, and that wasn't valid JSON. So our plugins down the chain were not working. Now, it was interesting because we finally figured this out, but if we would have read the documentation for CNI plugins, it's all right there. It says use standard error. So when we decided to use standard error, everything was working just fine after all. So luckily for us, there's a lot of reference material out there thanks to the open source communities around Istio and Calico. So in short order, we were able to create a LINKERD CNI plugin to meet our needs and contribute that source back to the LINKERD project. So there's just one more issue for us regarding the CNI plugin, and that was how to get it deployed on our nodes. So our Kubernetes cluster nodes come up and down constantly all the time because our Kubernetes team is doing upgrades and maintenance often. So because of this, there's a very small chance that when a pod comes online, it will get scheduled on a new node, and it has the LINKERD proxy, but that's before the CNI plugin has written the IP tables. So that means even though the pod had the LINKERD proxy, it would not be a part of the service mesh. So we had to figure out a way to work around this, and so because we couldn't use the typical daemon set installation that you would usually see with a CNI plugin. So it took some more time talking with our Kubernetes team, and we were able to basically bake the plugin directly onto our base image for our nodes. And so finally, we had a solution that would allow us to install LINKERD onto our clusters. But we're still not quite done. There are two more security requirements that we had to meet. We had to be able to audit all of the certificates that our service mesh was using, and we also had to make sure that they were all signed by the Nordstrom certificate authority. So remember that LINKERD has that identity service that is responsible for creating and issuing certificates to the proxies. Since that service typically handles all of the certificate creation and generation automatically using its own self-signed certificates, we couldn't meet these requirements out of the box. We needed to figure out a way to get these certificates from our Nordstrom certificate authority that we already had in place. So we chatted with the LINKERD engineers some more, and we decided to go ahead and code up a solution for us that would have the LINKERD identity service reach out to the Amazon private certificate authority we had to get those certificates. And we've been using the solution for a few months now, and it works great for us. It turns out that this particular approach isn't actually going to be merged into the upstream code, and that's okay. The LINKERD engineers are going to use another open source project, Cert Manager, to use for custom certificates. And I think overall, for the community, this will be a better solution because we'll be able to support more than just our particular AWS certificate authority. It also means that we are itching to contribute back to any Cert Manager pull request or issue that needs our help, and so stay tuned for that work. So now that we've implemented our changes and installed the LINKERD CNI plugin on our cluster nodes, let's check out our service mesh pods. Well, would you look at that? All of the LINKERD pods are running, and our service mesh is operational. So now I'm going to bring Hema back on to wrap it all up.
So how did we do in our rollout? We had challenges that I think any enterprise might. We spent a lot of time understanding the problem space and the tools we needed to integrate our services into the mesh. Even though we chose LINKERD, this may not be the right option for you. We went through a lot of iterations vetting our design with other teams in our security and infrastructure organizations. We also encountered problems as a result of our team not being cluster administrators. Installing in our cluster was not easy, but it gave us a chance to collaborate with the LINKERD team, which resulted in contributions towards a CNI plugin to benefit the community. Our service onboarding procedure surprised our development teams. Engineers came in expecting to spend a full 30 minutes and to make a ton of code changes. When they were done in the first 10, and they added in those 2 lines of code that you see up there. The feedback we received was overwhelmingly positive. The teams couldn't believe how easy it was and how much observability and tracing they were able to get by being part of the mesh. We also gave them the ability to opt out if needed. We still have a long journey ahead to make this a true service mesh by integrating all of our environments and continuing our service onboarding. We thank you for coming and open it up to any questions you may have about our initial process, the challenges we encountered, and how we made it enticing to our developers. Thank you. Yeah, there's actually a mic, I think, up at the back. We are still working on that solution. So at the moment, we decided that we were going to do cluster first, since that's the direction we want to move in. So we're focusing on that. Yes. His question was, how are you doing with your non-cluster resources? Yes, please.
Do you have any information on the CPU impact of using LINKERD? One of the reasons we've been reluctant to move down the service mesh path is some anecdotes we've heard about extremely high CPU requirements if you have high transactions per second. Has that been your experience with LINKERD? What kind of impact has it had for you?
Do you want to?
Yes, so we haven't seen any significant impact in our CPU usage as far as that matters to us, but we definitely recommend that you perform your own testing, and so you can figure out exactly what you're going to need. Yep.
Thanks. Great presentation. Thank you very much. When you initially did the evaluations of the different solutions, which versions of LINKERD, Istio, et cetera, were you comparing against each other?
I believe we started with LINKERD 2.3.
Yeah, it was one of the. This was about a year or so ago. So a lot of this stuff was new. We've been updating our tests as we go, but they were definitely some of the newer, earlier versions.
Again, great presentation. We have a very similar situation where teams are using a wide variety of technology stacks. So one of the challenges we faced is communicating the value of doing this kind of work to our engineering leadership. So what was most effective for you when you were pitching this work to get it funded? And then as a two-parter, what was the relative size of the team that actually ended up implementing this solution?
So initially, I think our main selling point was securing service-to-service communication. That's how we went about it. And our team size right now, we're about 6 to 7 engineers on our team. And then I think it's an additional 6 to 7 engineers on the Kubernetes team. So we try to collaborate with them to learn as much as possible so that we can actually make this work.
Hi there. Can you go into a little bit more detail about what made you choose LINKERD over the other options that you listed up there? I saw you mentioned memory footprint.
So that was one of our primary reasons. Our Kubernetes team had given us a set of requirements for it. So they were saying, please try and meet these requirements. So that was essentially what we worked off of. And at the time when we tested these, LINKERD worked really well to fit those requirements and the resources that we had. So.
Hi, great presentation. Two questions. How do you allow services to opt out? What kind of considerations goes in? Because once you have 2 services in the service mesh, do you always open a non-mesh path as well? And the second one is when you have to upgrade a service mesh. I'm assuming your team is the mesh operator for the developers. So what kind of considerations have you tested it? What kind of challenges, if any, you had?
Yeah, so the first question, what was the first question again?
Could you repeat your first question again? Sorry.
Just the ability to opt out of the mesh
right.
after having
Sure.
the opt-in in.
Yeah, so the ability to opt out really for us is only going to be viable during the migration period. We've got our sales that happen and holiday sales coming up and things. So it's important that as we're migrating to all in, that teams can also choose out. So that does mean that there's a path between services that is not in the mesh.
So once in, they can get out, is what you're...
We hope. I mean, I hope. But yeah, I think that's the idea.
That's the idea. And about the upgrade, if you have to upgrade to the mesh itself, LINKERD, the next version, what kind of challenges? Do you have multi-clusters? And what kind of issues, if any, did you face?
Yeah, so I mean, for us, it's been really straightforward and simple with LINKERD. They provide these dashboards and things that we can show teams. We've also used our own metrics and things that we have dashboards for. There really, so far, haven't been too many challenges that we've had to overcome as far as teams using the service mesh.
Great, thank you.
Yep.
Thank you guys for sharing your journey. I had a question on the fork of LINKERD that you're maintaining for the AWS custom certs. Mm-hmm. Any thoughts on genericizing that a bit and releasing that to the community?
Perhaps, yeah. So I know that the fork that we have, we don't really want to maintain super long term. So we want to eventually do something that's going to benefit everybody and get back into the main line. So what will probably happen is as LINKERD cert manager support grows, we'll probably create a cert manager issuer for AWS ACM PCA. And that will be the way that we contribute into the broader community.
So you mentioned about that it was an easy experience for your users to onboard into LINKERD. So were there any sort of additional steps that they need to follow? If so, did you provide any sort of tooling around that?
No, it was just the 2 lines that you saw were all they added to their deployment YAML, and they were part of the mesh at that point. Everything else, we had already done the platform work so that they could actually get the benefits from it.
And in terms of tracing, do you need to do header propagation by yourself, or does LINKERD handle that?
Yeah, so the LINKERD proxy will add its own headers, but the other services, if they want to have additional tracing, will need to add those headers, yes.
And did you provide any library to do so, or are they just solely responsible?
No, it's going to be up to those service teams, yeah.
Thank you.
Hi, great presentation. how much latency is being added at each pod level? Are you, and the second question, which is related, is, are you considering something at a per node level if this latency goes beyond certain threshold?
Could you repeat the first one again about latency?
How much latency is being added by the LINKERD proxy at a per pod level?
So the numbers that you saw up there were for 500 requests per second was about 3.7 milliseconds. And the 5,000 requests per second for our anniversary load was about 4.23, I believe, milliseconds. Could you repeat the second one?
Yeah, the second one is, since one end user request will span across multiple application pods, so what's the budget for the overall request that you've allocated, and is this something that is within the acceptable threshold, all the latencies, the cumulative latencies that will get added?
Unfortunately, I don't know the answer to your second question, so I'm sorry.
Do any of your applications have to use a corporate web proxy for public internet egress? And if so, how does that integrate with LINKERD?
I'm not aware of any, but I don't know all of our thousands of services off the top of my head. I would imagine there might be something out there, but we haven't run across that yet. So definitely if we run across something, maybe we'll have another talk about that.
Yeah.
Hi, how is the ownership done in your cluster? Like, who is managing the canary traffic? And I guess Kubernetes team manages Kubernetes, and you guys manage the service mesh. So who is owning the other features in the service mesh?
So for now, since we just started with the service mesh, our team tries to manage everything related to the mesh itself. And then the Kubernetes team does anything that's related to cluster, like upgrades, version upgrades, things like that.
Okay. So the application developers are actually managing how much percentage of traffic goes into which version and everything?
I believe so, yeah.
One more question. How is the ingress managed, like the traffic that goes into the mesh? Is it per tenant, or is it common for everyone?
Yeah, so one of the other aspects that our team is looking at is some kind of shared ingress controller. So we want it to be common for everybody.
Yeah.
Hi, thanks for the presentation. One question, first one easy. What was the load testing tool you used?
Work2.
Work2?
Yep.
Okay. And the second question is, I remember seeing the slide where you have multiple GKE clusters, say AWS and GKE. Were there any challenges with getting LINKERD to span across the clusters, across cloud?
Yeah, so right now we haven't solved that part of it, but we're definitely looking into how we can do that. So there will probably be challenges. Yeah.
Okay, thank you.
Yeah. Sounds good.
Okay, so we need to keep things moving, but you can always ask the presenters questions on the side after this. Thank you so much, Hema and Cody.